Hey, what's going on, guys? Xiangqi here. So we're continuing our work on Deobfuscating, world's smallest chess program written in JavaScript by Oscar Toledo. But before we start, I have a good news for you guys. So yesterday I was lucky to get in touch with Oscar himself, and he allowed me to go with this series on Deobfuscating his program. So I was a bit concerned that he's kind of selling the book that describes how this program works in particular. And by the way, here you can have links to both the paper book, like the hardcover, the soft cover, and the ebook even here. So all the links are available, and yeah, also the link to his website, which is this one. We're gonna be referencing this website today as well. And yeah, Oscar turned to be a very nice guy, and I'm so happy that he actually gave me that permission to continue with this series. I was just thinking maybe some copyright issues or something, but he said like, I don't have any problem, so yeah, feel free to continue with your series on the obfuscation. I don't have any problem, as many people before have published the obfuscation effort. Nice video. So Oscar, thank you so much for your feedback. And so as you can see here, guys, so we have no problem, as many people actually been doing this before. Well, once I've seen one effort to deobfuscate, not exactly this version in particular, but anyway, but that wasn't 100% complete though. So yeah, and I didn't dive into that. So again, like, my research is done completely from scratch, only based on my own experience. But anyway, just wanted to give an idea. So yeah, now without further ado, we can actually move on. So don't need this one anymore. So in the last video, we've added a function to draw the internal board state. We have figured out the piece encoding and the board representation. So now it's time to figure out how the site to move is being encoded, right? And well, and then also, well, then it's really, the code is very tight, so it's really hard to predict how in particular things would be going. So I just make some effort before starting this video to kind of dig a little bit into the source code to figure out a few essential things to consider. So it's just a raw preparation, but I have no idea how this goes, because I really want to keep this kind of live. But anyway, so the very first thing, the very first variable to deobfuscate next would be the search depth, and the way it's being encoded here in this implementation is quite pretty tricky. And just so what can help us in this regard? So here on Oscar's website, if we go to the chess programs and then we go to the JavaScript chess here, as where we've been I'm sorry guys, already, and we just search for a depth. So here you see like the play level is fixed at 3 play depth. Well, it's not exactly for the version that we're working with, so he mentioned somewhat a different version. But anyway, here where we have two calls of X, which stands for search, we have two calls in a row, and this very last parameter is, well, it's actually not, well, it's last here, but well, I figured that out using the trial and error method. So here is the parameter being responsible for a search depth. I'll now demonstrate you how this works, but before that, let me mention another important thing. So you might be wondering why on earth to make two searches in the row. And again, like, as we will see later on, so this search gives the search for a desired depth. So in this case, this is 2 play depth, but we can increase this, even though the performance would be dropping. But anyway, still hope that's kind of makes sense. But you might be wondering, why do we need this next search after? Well, the most logical assumption, well, bear in mind the fact that this tiny chess program is a key capture engine, which means it doesn't have a square attack function to figure out whether the king has been exposed into a check or not, but instead king can get captured, and in that case we need to return a proper score, like results in, I don't know, infinity, minus infinity, like some mating score. I'm not sure yet how this is implemented, but that's how the king capture engines work in general. So I guess this is kind of it. So, well, yeah, just to give an idea. So let's run. Yeah, let's go back. So I just wanted to give an idea where did I come with this. How do I know that this should be a search depth? So as I've been mentioning, so here we should have like site to move, search depth, and another two parameters are not what I've been assuming in the previous part, or at the very least now I think so, but we'll come to this a little bit later on. So now, so let's update and we can play, and you see like it moves kind of like instantly, okay? But how can we increase the search depth? So say here we put 3, and this would probably be around the same. However, well, that doesn't mean that he plays it silly now. It's just like a better move. It also have the randomization, so it doesn't mean that much currently. Okay, so yeah. All right. So, but if we say put 4 here, then suddenly it would be thinking much slower, because, well, I'm still not sure whether it uses alpha beta search or just the brute force algorithm. Now I think that probably it's using the brute force algorithm. However, well, at the very least I can see the alpha and beta values being sent recursively, which is absolutely essential for the alpha beta pruning. So that's why I may assume that probably it's using just the eninge brute or the brute force search. But at the moment it doesn't matter that much. But you see, like, it now takes longer for a computer to think. So from here we can state that the third parameter E stands for search depth. So now let's try to replace this E by, so I want to make it like so. So I just want to replace this E. So yeah, probably would be going like 1 by 1. We don't have it here. Okay, so only like there. Okay, so Control H to replace with, actually, yeah, space and search depth. So depth. We can use search depth as well. Okay, search depth, and I want to replace all part here. Okay, search depth. And if I didn't break anything, this still should be capable of playing chess. Okay, undefined reference. 114. Excuse me. 114. Oh man, that wasn't clever. Yeah, we have them. Okay, so alright, so let's, in this case, let's take just the bare E. Oh man, this is not good. Well, okay. In this case, we're gonna be walking like step by step, I believe. Oh, I'm sorry. So I don't even know. Yeah, so replace. Okay, previous, replace. Replace. replace like this. Here. And yeah, I guess this is it. So let's have a look. Yeah, let's have a look. Okay. Are you still alive? Yeah, probably. Seems like. Yeah, seems like it's still alive. Okay, so yeah, let's try to set it back to 2 or maybe 3. Yeah, let's set it back to 3. All right, so yeah, seems like it is still alive. And now we have the search depth variable being defined, which we know kind of 100% for sure, right? Okay, so another thing which is not really that essential at the moment, but still we know this for sure, that this W function stands for like to render the board. So here we want to render board to screen. That's pretty it. So let me just find this W. All right. So not that many instances, right? And I just want to replace this with, let's call it draw board. Okay. And replace all, save. And I really hope this should be working as before. Okay, great. Okay guys, so the next thing is the site to move. Yeah, so my research tells me that the very first the C argument, the argument the C stands for site to move, and here is the line to change the site to move. So this value, this C takes, so if we search for all the instances of the search like this, so you see like we have either 8 here, or alternatively we have 0. Okay, so only 8 or only 0, and bear in mind the fact that the site to move for a player and for a computer are kind of like pre-coded, so computer only plays with black. This lets me think that this is the matter of a site to move. Now if we have, so just to give another idea, so if we say 0 bitwise or with 8, this would be 8, and then if we say 8 bitwise or with 8, and this is going to be 0, so it switches like every time we come into the search, the site to move would be either 8 or 0. So that's because we want to search recursively with a given depth, and like make the move for white, make a move for black, for white, for black, and so on. It's not that simple how it might seem. So another thing to consider, so also you might be wondering like why it's so actually the next thing to consider, yeah, so before anything else, the next thing to consider, we need to know whether 0 stands for white and 8 for black, or on the contrary. So how can we do this? So first of all, let's get rid of the recursive call. So I no longer want to the engine actually searching. Instead, I just want it to kind of stop, wait for user input, and print the board. Okay, like this. So after making a move, and also after taking back. So yeah, let's have a look. It's not gonna be playing chess any longer. However, if you see right over in here and just keep pressing enter, you see like it's searching the moves for a certain side to move, for white in this case, right? And this is it. And now if say here we change this to 8, this should start searching for black. So just to invoke the routine, and now it's searching for black. But can we assume that 8 stands for black and 0 stands for white? Well, I thought so, but actually here, so let's have a look. It's another thing. So every time we hit the search, I just want to say console.log, and let's say search called with args, and now just to list the args, so C and then plus space plus H. Well, this mysterious H, I have no idea what this stands for at the moment. And search depth plus, and another mysterious parameter, which probably distinguishing between the internal search call as it works here, or the external if user just initially invokes the search. That's my current assumption, which might be horribly wrong later on, which might turn out horribly wrong, but might be working as well. Okay, and here console log. So here we'll have the actual site to generate moves for, well, at least in theory, and plus C. Save. Now let's have a look what we got here. So the very first thing that kind of like doesn't make me happy is that we have the search called with this args, which our initial argument, so we didn't define this very last one. This is okay, but then you see like it gets called again with some different parameters, and we don't really want this to make sure that everything is working like transparently. So here is this another sub call of a search. I have no idea the purpose of this, so for now we can just get rid of that. And so yeah, I just need to press enter until it generates all the moves. Okay, and now as you can see, so we only deal with our initial call, which stands like just when the user calls when the user calls the routine initially. That's pretty it. So actual site to generate moves for is opposite to what has been called. Okay, and it actually generates moves for generates moves for black. So the actual site to move is black, and based on this we can assume that 0 stands for black and 8 stands for white pieces. But there is another way of how we can not make 100% sure, but what we can assume. So I believe that the site to move is also encoded within the pieces. So I mean, like just bitwise end in the piece code with the 8th bit. So it's something like, so it's here if we say like the 9 bitwise ended with 8. So if it's true, then it says this should be a white piece, otherwise this should be a black piece. So let's go for it in binary. So this is 8 in binary, this is 9, right? Bitwise end with 8, and so this would be like this, 8, right? So this bit 1 and 1 would be 1, 0 and 1 would be 0, 0 and 0, 0, 0 and 0, 0. Okay, so well, I think that this is the case, and this works for all the white pieces. So that's another like reason to think that 8 actually stands for white pieces. So let's take, I don't know, 13, let's say. Oh my god, how to turn 13 into binary? So let's say 8, 9, and this plus 3. Nope. 1, 2, 4, 8. So 1, 2, yeah, 3. 3 plus 8 is 12. Oh my god, guys, sorry, just I can't calculate in binary in that great way. So let's say 13 and convert this to binary. Yeah, yeah, it's not exactly. It should be like this. Okay, so here's what we got, and if we just bitwise end this with just I'm a bit confused by the symbol here, but with 8, yeah, this gives us 8 in a binary. In the decimal, this would be 8. Yeah, so seems like it's working. So it seems like the 8th bit, so this bit, is always available for whatever white pieces. So 9 works. Yeah, so actually it's greater than 8, so it always have this this bit being turned on. So this gives us an idea why we have 8, why 8 stands for white pieces. So piece encoding and color, let's say here I want to say color or side to move, side, or yeah, let's just say color encoding. So yeah, paste. So here we have white is 8 and black is 0. I'm just wondering, yeah, should I centralize this? Well, I think I can, right? And yeah, so yeah, so 8 for white and 0 for black. And again, like right over in here, we call, initially we call this for black, right? So like forcing black to move. However, here within this recursive stuff, it just searching for white. Well, there is definitely a relation between so this side to move here and side to move here is the opposite. However, if we just swap them to different, like if we make this zeros and the one here we make it 8, it's not going to be working, just going to be doing some gibberish. So I can't say more about that at that point in particular at the moment. But we've just revealed this side to move, so let's search for the C, and yeah, it's gonna be a long story, so Control H, let's call it side to move, and so starting from here, here. So replace yeah, can make it here as well. So the most essential part is here. Here. Well, probably there is some online deobfuscators that would be doing this better for me. But anyway, manually inspecting every place where the variable change occurs also makes perfect sense. Next. Yeah, by the way, here we want to replace as well. Okay. So nothing here. All right. Previous. Next. Replace. Next. Yeah, I want to replace here, obviously. Replace here. Here. Yeah, this seems to be it. And now the moment of truth. So if we uncomment this stuff back, then it should still be capable of playing chess. Otherwise, I've horribly ruined something. Well, no, not exactly. So to make 100% sure that it would be playing chess, I need to uncomment this part as well. So I just want to check if the variable renaming works, and then we'll comment this back to reveal the mode generator variables. Okay, so let's have a look. Oh, sorry guys, we don't want this. Now this is gonna last forever, so just want to reset stuff. Okay. Yeah, I don't want to log anything here, so we don't want this. It's just gonna take ages. Right. Yeah, I'm sorry, just hanging a little bit here. Yeah, it's a bad idea to record to print whatever to the console when this thousands of recursive calls are happening. Copy. Oh, it is, right? Yeah. No. So yeah, good news that it seems like we're still capable of, yeah, playing chess, which is a good news. All right, yeah, great. So in this case, so do I really need this information? Well, probably I don't need this information any longer. Probably, yeah, I can still keep this initial, yeah, this initial, the lock of the arguments for a search call. I don't need this currently at the moment, so I don't want this part at the moment as well. All right, and I want to get rid of the recursive call for now, and I want to restore my alerts here. Okay, so yeah, now we're generating moves for a given site to move. Okay, this is really nice. This is really nice. To be honest, guys, what I didn't yet manage to figure out on how to make it is how we can actually, how can we, can I actually, hold on a sec, can I run the, just wondering, I want to be able to run the search function like this, just directly from the command line without a need to make a move. So let's say search and 0, 0, 1. Okay, yeah, perfect, now works. So here we're generating the moves for whites, but again, like it's already kind of swapped. So we ask to generate for black, but then internally it swaps to generate the moves for white. But in this case, it doesn't really matter that much in particular. What really matters in this regard is that by swapping this site, no matter what the values currently are, because we've seen why exactly 8 stands for whites and white doesn't stand for black because of this, because all of these values have the 8th bit being equal to 1 always. So that's the way how to distinguish white pieces from black pieces. That's my assumption. That's how it works in, similarly it works in Micromax by Harm Gertmüller. I've been implementing this kind of thing in the past as well. So that should be it. It should be true. Well, if it's not, we'll definitely figure out later on. But I think for now, we can assume that that is true. And if we if we just swap the site, yeah, the good news is, you see, like it starts generating the moves for black pieces, which is absolutely fantastic. So, which means in particular that from now on, we can reveal another bunch of variables, like what they are and what in particular are they doing, like this one. So board from square, like board. So this definitely stands for board from square because we reset it to make it like equal to 0. And when we print the board, we saw like it just goes to like being empty here, and so on. So this T stands for target square, and in the target square we do restore the captured piece. So R should be the captured piece, and O should be the current piece, the piece that is currently moving. So that's a very simple assumption based on just the bare make, move, and take back functions from the move generator. But we're gonna be covering this in the next series, in the next video within this series on Deobfuscating, world's smallest chess program in JavaScript written by Oscar Toledo. So I really hope to see you in the next video, guys. So that would be the same live stream format. I dig a little bit into the code to prepare some, like a chunk of content for you guys to tinker with, to start tinkering with, to tinker around with, and hopefully that would bring some fun as well. Okay, so this is it from my side. Thanks for watching. Thanks to Oscar Toledo for letting me deobfuscating his code, and this is it from my side, guys. Until the next time, and take care.